Okay, so the title on this notebook file says volume by integrating, but this first few, your sheet will say area and volume. So the first question is about area. It says determine the area under the curve y equals inverse sine of x for 0 to 1 using two different methods. So one method is obviously finding the area underneath that curve with respect to x. So you're really looking for this area here. But another method might end up being easier in some cases, is to find the area with respect to y. So that would actually be here. So basically taking your x and y axis here, flipping your paper up, so like the x is going up and you're kind of turning sideways. So your x and y this way. And then your graph, it's of this. So then you're finding the area, so it looks something like this. You're finding the area here and subtracting it. Okay, so kind of hard to explain when I can't use my hands to show it. But so with respect to y would mean find this area and then subtract from the area of the rectangle. Okay, so that's what we're going to do first. This is a little bit easier integration. So if we were to show this, as I said, with respect to, so here we've got y equals sine inverse of x. So if we solve for x here, we get x equals sine y. Okay, so same function. This is solved for y, and this is solved for x. So anytime you're integrating with respect to y, you want x equals. So here, we're going to integrate with respect to y. Okay, and then for the interval for that would be between 0 and pi over 2. And then subtract from the entire rectangle formed with the x and y axes. Could be a different position. Well, I'll just leave it as rectangle. It really depends where your graph is located. Okay, so area. So the area of the rectangle minus the integral of the function with respect to y. Okay, so what's the area? It's 1 unit wide and pi over 2 high. Function with respect to y is sine of y dy, and that's an easy integration. Oh, I forgot to put in here. So now, with respect to y, it's going from 0 to pi over 2. So now we're subtracting. Integral of sine will be negative cos. Okay, so pi over 2 minus, well, that can be plus cos y from 0 to pi over 2. So cos of pi over 2 minus cos of 0. Cos of pi over 2 is 0. Cos of 0 is 1, so that's going to be minus 1. So you can leave it like that. That would be units squared. Or it would be pi minus 2 over 2 units squared. If you showed it as one fraction. Really doesn't matter. Okay? So, pretty easy integration when we do this with respect to y. Next method, we'll do it sort of the normal way. With respect to x, it's just a harder integration. Okay? We're going to have to integrate inverse sine of x, or arc sine of x. Okay, so method 2, we're going to integrate with respect to x. So that means it's going to be from 0 to 1 of sine inverse x dx. And you can see it's a little bit harder. Take a look at your formula sheet. There isn't anything that can help you integrate that. So if you can't find something, then think about other methods. Substitution obviously doesn't work, but perhaps integration by parts. So let's let u be sine inverse x, or arc sine x dx, okay, because you can find that in your formula sheet in terms of du. Du is 1 over root of 1 minus x squared dx, and I shouldn't have a dx up here. Just a sec here. So this, just going to fix this up. So this is, there we go. And so u equals sine inverse of x. That means dv is equal to dx. When we integrate that, we get v equals x. Okay, so integration by parts, is uv. So that's going to be x sine inverse x from 0 to 1 minus the integral of v du. So that's going to be x over root 1 minus x squared dx from 0 to 1. Okay. You can start substituting in for the first term. We still have to finish integrating. Okay. In this case, I notice, so maybe you might think trig substitution, but we've got an x up top, so it's not quite as straightforward, right? So if I let, so a different u, so maybe let's use a t. So if I let t equals 1 minus x squared, then dt equals negative 2x dx. So that would be negative 1/2 dt equals x dx. Okay, and then that's going to help me out big time. So I'm just going to copy this out for now. All right. So I'm replacing x dx with a half dt, negative 1/2 dt. So actually, I'm going to bring that out front. So that's going to make that plus 1/2, and then dt. And then it's going to be 1 over the root of 1 minus x squared, which is root of t. Okay. Now, what are my new indices here? So lower boundary. So when x is 0, that means t would be 1. And when x is 1, t would be 0. Keep them in that order. Don't change them because it'll change the sign. Okay, so now if I integrate this, that's just t to the negative 1/2. So this is going to be t to the positive 1/2 over 1/2. And then from 1 to 0. And you'll notice those divide out. Okay, so now I'm going to start substituting it. So 1 sine negative 1 of 1 minus 0 sine inverse of 0. So that goes away. Plus, so t to the 1/2 is the square root, so square root of 0 minus the square root of 1. All right. So when we're dealing with sine inverse of 1, so we have to think about what angle gives you a sine value of 1, and it has to be between 0 and pi. That's going to be pi over 2. And then minus 1, which is the same as when we did it using the first method. Okay, which was easier? Definitely the first method. Okay. Okay, now we get into some volumes. It says a cone is formed by rotating the area between the x-axis, y-axis, and the line y equals negative 2x plus 8 about the y-axis. So that gives you a hint that we need to integrate with respect to x. So let's do a little sketch here. Okay, so negative 2x plus 8. So y-intercept of 8, negative slope. So there's your line. Okay. So it says it's going to rotate that. So a cone is three-dimensional. We're going to rotate the area between the x-axis, y-axis, and the line. So basically we have to take this and rotate it. So when we do that, we're going to end up getting a cone, right? So this line is y equals negative 2x plus 8. I want to get it with respect to y. So solve for x. So what would that be? That's going to be, I'm going to bring the 2x to the left, and then I'm going to have, you can even go 8 minus y if you don't want the first term to be negative. And then solve for x. Okay. And then what you're going to go from 0 for y up to this point here, the y-intercept. Well, we can tell what the y-intercept is. It's 8. All right, so we are going to calculate the volume. So it's pi times the function squared, in this case with respect to y. So 8 minus y over 2 squared dy. And for the y values from 0 to 8. Okay, think about, again, taking this x-axis here, kind of flipping it over. So flipping your page and looking at the y-axis going upwards, kind of turn sideways, and the y-axis horizontally going to 8. So it's from 0 to 8. So let's expand this out. So that's going to be 64 minus 16y plus y squared over 4. I'm going to bring the 4 out front. Okay, now let's integrate. So pi over 4. So it's going to be 64y minus 16y squared over 2 plus y cubed over 3 from 0 to 8. Okay, that out. So now I'm going to have 64 times 8. 2 goes into 16 8 times, so minus 8 times 8 squared plus 8 cubed over 3. So that's when I substitute 8 in. When I substitute 0 in, I'm going to get 0. All the terms have a y in it. So I kind of like to put the minus 0 just so the reader knows that I did substitute that in. Okay, and then we want to evaluate that. If you notice here, 64 times 8, well, that's the same as 8 times 8 squared, because 8 squared is 64. So really, this goes to 0. And so it ends up being pi times 8 cubed over 12. So 8 cubed is 512. And then that reduces to 128 over 3 pi, and that's units cubed. Okay. Yeah, you could have done this using volume of a cone. Is 1/3 times the area of the base times the height. So in this case, 1/3 pi times the radius would be 4. You need to know the x-intercept here, so you could easily solve. So when y is 0, x would be 4. So that would be 4 squared times the height is 8. And simplifying that is 128 over 3 pi. So in this case, it forms a very common shape that we know the formula to. The next one, for example, doesn't. So you can't just check it that way. Okay, so this one has, it's a bell shape, and then we're rotating it about the y-axis, okay, to form a three-dimensional shape graph. For this one, put it on your paper. Can't remember if we put it on your notes paper. Anyway, it does look like this. So it's a bell shape that's going to be rotated about the y-axis from the x-axis. So starting at 0, draw an x and y-axis through it. So it goes to 0. It actually tells you the height of the bell is 8, but that kind of makes sense. It's the y-intercept. So when you put 0 in for x, you get -4 times -1, which is +4, which is 8. Okay? And so we want to rotate this about the y-axis, so we actually have to get our function in terms of y. So here's our function. We need to isolate x. So bring the 4 over, divide by -4. So you might want to show this as negative y minus 4 over 4. Keep it in brackets so you don't forget if you have messy writing. And then that means x minus 1 equals the cubed root of negative y minus 4 over 4. And then add 1 to that. Now, if you want to make this radicand a little simpler, you might incorporate the negative, so expand that out. So that would be 4 minus y over 4. Might be a little bit easier when you're integrating not to have as many brackets. So now our volume is, we're doing a bell. So volume will be pi. So from 0 to 8 of the function in terms of y squared. So that's going to be 3 cubed root of 4 minus y over 4 squared dy. Think about what that means. That's really 4 minus y over 4 to the 2/3. Okay, so then you might want to, I forgot the plus 1, sorry. Plus 1. Okay, so now it actually expand out the brackets, so square everything, and then I'm going to use brackets instead of radical sign. So when I square the cubed root, I get 4 minus y over 4 to the 2/3. Then the product of the two terms doubled will be plus 2. And again, I'm going to use powers. So 4 minus y over 4 to the 1/3. And then plus 1 dy. Separate that. Okay. Then integrating here. So really, this is a negative. You can do a substitution if that makes it helpful for you. So a substitution of u equals 4 minus y over 4. So just replace everything there because it's all raised to the 2/3. So then du equals negative 1/4 dy. And then dy is equal then negative 4 du. Pi Okay, what are we going to have here? So we're going to have the integral of u goes in there, so u to the 2/3. So it's going to be negative 4u to the 2/3 du plus 2 integral of negative 4u to the 1/3. I'm just going to do this a little bit. See if I can fit it in here. Du. And then plus the integral of, well, that would still stay as dy. I didn't have to do any substitution there. So that would still be 0 to 8. For my u's here, when y is 0, this will end up being 1. When y is 8, this will end up being negative 1. Okay, so now, got to close the brackets on that. And so now we'll integrate this. So negative 4, that's going to be u to the 5/3 over 5/3. Maybe I'll do this all together before I do my indices. So then that's going to be negative, so subtract 8, u to the 4/3 over 4/3 from 1 to negative 1 plus, that's going to be y between 0 and 8. Okay, so, and that actually needs to be multiplied. So basically here we need another set of brackets because of the pi. So I'm just gonna simplify within here. So that's gonna be negative 12 over 5 u to the 5/3 minus 24 over 4 minus 6 u to the 4/3 from 1 to negative 1. Plus, now I can do here, that's going to be 8 minus 0 multiplied by pi. Okay, so negative 12/5 times u, so negative 1 to the 5/3 minus 6, negative 1 to the 4/3 minus negative 12/5, 1 to the 5/3, obviously that's 1, minus 6, 1 to the 4/3, plus 8. Okay. So, cubed root is a negative to the 5th, that's odd, so that's negative, times a negative is a positive. Cubed root is a negative to the 4th is a positive, so that's going to be minus 6. It's going to be negative 12/5 times 1 minus 6, and then plus 8, all times pi. So 12/5 plus 12/5 is 24/5. Negative 6 plus 6 is 0, plus 8. So that's going to be pi times 64 over 5. So the volume is 64 over 5 pi units cubed. Okay, so a lot of work on that one, but much easier than, well, it was rotated about the y-axis, so you don't really have a choice, right? I guess you could change it into a function. Well, we did it in terms of y, and then convert it back to x, but it's the same type of work. Okay, a lot of algebraic work. Okay, so just another method that you can use, add to your tool belt, as we say, your toolkit.